In this chapter, we're going to be talking about alkenes. And in a chapter on alkenes, usually every book will talk about degrees of unsaturation. Degrees of unsaturation talks about the numbers of carbons on the number of hydrogens that are on a carbon compound. We already know, let's look over here at this compound, right here. We already know that this compound every carbon has to have 4 bonds. So if you have just 2 carbons bound to each other, you've got to surround it with hydrogens until you get 4 bonds on the carbon. In order to form an alkene, though, we put a double bond in there, and that already makes 2 bonds. So in order to put that double bond in, we've got to remove 2 hydrogens. So if we look at the formula for ethylene, it's 2 less hydrogens than for ethane. And this is what we find for all alkenes. This is the general formula for alkenes right here, CnH2n. The formula for alkanes is CnH2n plus 2. What is the difference? You see, it's just that 2 hydrogens. So for every double bond, you have to remove 2 hydrogens to form the double bond. If you are given a formula, in order to find out how many potential carbon-carbon double bonds are in there, you count up the number of carbons and you count up the number of hydrogens and you compare it and you see how many hydrogens are deficient. The number of pairs of hydrogens that are deficient is what's called the degrees of unsaturation. So let's look at an example. For instance, we're given this formula C8H14. If I do 2n plus 2 for 8, I get 16 plus 2 more, which gives me 18. So a fully saturated 8-carbon compound would have 18 hydrogens. But there are 14 hydrogens in this compound, so that's 4 less hydrogens than what you would need for full saturation. We say that the compound has 2 degrees of unsaturation because potentially there's 2 double bonds in there. A double bond is basically called a degree of unsaturation if you haven't figured out. So 1 pi bond is 1 degree of unsaturation, 2 pi bonds, 2 degrees of unsaturation, etc. Another way to lose 2 hydrogens or have a degree of unsaturation is to have a ring. So if I have a ring, let's say cyclohexane, if you look at plain hexane, it's C6H14. If I look at cyclohexane, though, it's C6H12. In order to close that ring, the 2 ends on hexane have to have a hydrogen each removed for them to bond to each other and make that ring. So a ring causes 1 degree of unsaturation. If I look at C8H14 isomers that are possible, there's more possible than these, but let's just look at 3 possibilities here. You can see this is C8H14. There's 1 ring and 1 double bond. You can count up all the hydrogens if you want to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And in this compound, it's C8H14. How do I know it's C8H14 without even counting up the hydrogens? I find there are 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8, and there are 2 degrees of unsaturation. So I know it's C8H14. And if I look at this compound, I would find there are 8 carbons. And because there's 2 rings, that's 2 degrees of unsaturation. So I know it must be C8H14. So let's look at C6H10. There are 2 degrees of unsaturation here. What are the possibilities? We can have 2 double bonds. We could have a triple bond. Notice a triple bond has 2 pi bonds. Each pi bond requires 2 hydrogens to be lost. Or it could be 2 rings. like this bicyclo compound. Or it can be a ring and a double bond, like cyclohexene. So there's many possibilities for this. So what if you have some heteroatoms like oxygen, nitrogen, or a halogen? Well, let's look at the halogens first. If you look at a structure that has a halogen in it, you will find that to put a halogen on, you have to remove a hydrogen. So if I'm trying to figure out how many double bonds are there, all I need to do is replace the halogens with the hydrogen, and I get an equivalent formula for counting degrees of unsaturation. So if I look at this compound, 4 carbons times 2 plus 2 would be 10. 6 plus 2 is 8. So 10 minus 8 is 2 hydrogens. So this has 1 degree of unsaturation, just the same as this compound. If I look at an oxygen, what we will do is look at putting a single bonded oxygen onto a carbon. What I have to do to put that single bonded oxygen on the carbon is to remove one of the hydrogens. Then when I put the oxygen on, it has to have a hydrogen on the outside if it's going to have all single bonds. So if I look at a compound that has an oxygen in it, I can just cut the oxygen off to get an equivalent number of an equivalent compound that has to determine for the purposes of determining degrees of unsaturation. So this compound and this both have the same number of degrees of unsaturation. So all I have to do is say 6 times 2 plus 2 is 14. 14 minus 10 is 4, so this compound has 2 degrees of unsaturation. If I look at nitrogen, I'm going to remove a hydrogen to put a nitrogen on. But when I put the nitrogen on, I have to put 2 hydrogens on the nitrogen to give it all single bonds, because it must have 3 bonds. So if I look at a compound that has a nitrogen in it, every nitrogen really requires 1 more hydrogen than what the compound would have if there were no nitrogens. So if I look at this compound here, what would be the equivalent count for it without the nitrogens? Well, if I remove the nitrogen, I have to remove 1 of the hydrogens to give it an equivalent degree of unsaturations. So C5H11N gives the same degrees of unsaturation as C5H10. So both of these compounds have 1 degree of unsaturation because 5 times 2 plus 2 is 12. 12 minus 10 is 2. 1 degree of unsaturation. So to summarize what you just learned, to determine the degrees of unsaturation, count the pairs of hydrogens missing from a CnH2n plus 2 formula. To determine if you have halogens in there, you add the number of halogens to the number of hydrogens. If you have oxygens, just ignore them. If you have a nitrogen, for every nitrogen, you have to have 1 hydrogen removed. Okay, so now we have some problems for you to try. Go ahead and try these problems by pausing the lecture, doing them, and restarting to check your answer. All right, so the first compound here, what I'm going to do is do 9 times 2 plus 2. That's 18 plus 2, which is 20. The number of hydrogens and bromine added together is 14. 20 minus 14 is 6. So there are 3 degrees of unsaturation for this compound. Here, 6 times 2 plus 2 is 14. Minus 6 is 8. 8 divided by 2 gives you 4. So there are 4 degrees of unsaturation. If I look at this compound, I automatically take the nitrogen off and 1 of the hydrogens. That gives me C5H4. 5 times 2 plus 2 gives me 12, minus 4 gives me 8. That's 4 degrees of unsaturation. If I look at this compound, I can do it by sight. A ring plus a double bond gives me 2 degrees of unsaturation. If I look at this compound, again, I can do it by sight. There is 1 double bond, 2 a ring, 3 a ring, 4 a ring, 5 a ring, another double bond is 6, and another double bond is 7. So